many efforts to reduce transmission of diseases like COVID-19 and the flu have focused on measures such as masking and isolation. But another useful approach is reducing the load of airborne pathogens through filtration or germicidal ultraviolet light. Conventional UV sources can be harmful to eyes and skin, but newer sources that emit at a different wavelength, 222 nanometers, are considered safe. However, new research from MIT shows that these UV lights can produce potentially harmful compounds in indoor spaces. While the researchers emphasize that this doesn't mean the new UV light should be avoided entirely, they do say the research suggests it is important that the lights have the right strength for a given indoor situation and that they are used along with appropriate ventilation. The findings are reported in the journal Environmental Science and Technology in a paper by researchers at MIT, Aerodyn Research, and Harvard University. While this research team usually work on issues of outdoor air pollution, during the pandemic, they become increasingly interested in indoor air quality. Usually, little photochemical reactivity happens indoors, unlike outdoors where the air is constantly exposed to sunlight. But with the use of devices to clean indoor air using chemical methods or UV light, all of a sudden some of this oxidation is brought indoors, triggering a potential cascade of reactions. Initially, the UV light interacts with oxygen in the air to form ozone, which is itself a health risk. But also, once ozone was made, there is a possibility for all these other oxidation reactions. For example, the UV can interact with the ozone to produce compounds called OH radicals, which are also powerful oxidizers. Volatile organic compounds are there in almost all indoor environments. These oxidants react with them and make the oxidized volatile organic compounds, which in some cases turn out to be more harmful to human health than their unoxidized precursors. The process also leads to the formation of secondary organic aerosols. Again, this stuff is harmful to breathe, so having it in our indoor environment is not ideal. The formation of such compounds is particularly problematic in the indoors because people spend so much of their time there, and low ventilation rates can mean these compounds could accumulate to relatively high levels. Having studied such processes in outdoor air for years, the team had the right equipment in hand to observe these pollution-forming processes indoors directly. They carried out a series of experiments, first exposing clean air to the UV lights inside a controlled container, then adding one organic compound at a time to see how they each affected the compounds that were produced. Although further research is needed to see how these findings apply to real indoor environments, the formation of secondary products was clear. The devices that make use of the new UV wavelengths, called krypton chloride eczema lamps, are still relatively rare and expensive. They are used in some hospital, restaurant, or commercial settings rather than in homes. But while they have sometimes been touted as a substitute for ventilation, especially in hard to ventilate older buildings, the new study suggests that is not appropriate. Their finding was that these lights are not a replacement for ventilation, but rather a complement to it. The results so far are from precisely controlled lab experiments with the air contained in a Teflon bag for testing.